These are your double angle formulas. Memorize them.
Now let's apply that double angle formulas to some problems. Problem number 1. First step, we multiply this out. You know, foil it. First, outers, inners, and last. So this and this gives you sine squared theta plus this and this, which gives you sine theta cos theta, and the inner, which gives you again another sine theta cos theta, so you just make this a 2. And then last, cosine, so that's cosine squared theta. Now, as you know from Pythagorean identities, this and this, sine squared theta plus cosine squared theta, that equals 1 plus 2 sine theta cosine theta. Okay, and now this part right here, that is from the double angle formula. That equals sine 2 theta. So that's 1 plus sine 2 theta. And guess what that equals to? Look, they're the same. Yeah, we did it.
Let's go! Inverse trig functions! Yeah!
Alright, so this question is asking at what angle does cos x equals 1? And at 0, it means when cos equals 1. You could also do this by, in the calculator, by cosine negative 1, 1. It only works for capital letter A, and capital A is inverse cosine function and consists of some answers. Yeah, so it's the same thing as this, except it's small case A, so it doesn't count up any answers. So the answer is 0 and 360. For this one, same thing as this, so you only have one answer because it limits the degrees. And for this one, it's 30 and 150. For this answer, 150 is also positive because all students take calculus, ASTC, and then 150 is that second quadrant, and it only works for some, and it's positive.
So now we're going to take it up a notch. The first thing we want to do is convert 0.5 to half so that it doesn't confuse you. Now we know that our cos of half is 60 degrees because the angle at which cosine is 60 is the angle at which cosine x equals half is 60. So then sine of 60 degrees equals to radical 3 over 2, and that's the answer. For this one, first we're going to solve this part, and arc tan 1 is 45 degrees because at 45 degrees tan equals 1. Tan 45 equals 1. So then cos of 45 degrees is radical 2 over 2, and that is your answer. For this one, it's a little more complicated. We have to draw a triangle to help us figure out which is like the missing side. So since tan is equal to opposite over adjacent, so this is the right angle, and this is the angle we're starting from. So we're going to flip the opposite angle of this is radical 7, and the adjacent angle is radical 3. Just 3. So then to find this angle, we have to do Pythagorean's theorem. So 3 squared plus radical 7 squared equals this angle squared. So we get 16. And radical 16 equals 4. So this angle is 4. Now for cosine, which is adjacent over hypotenuse, then we take the adjacent angle, which is 3, and the hypotenuse is just 4, so we get 3 over 4. And that is the final answer.
Okay, now we're going to show you how to graph the reciprocal trig functions. Okay, so you guys know about the normal trig functions and how they look in graph, right? Sine, cosine, and tangent. Just going to make this big for people to see. Let's see. For the reciprocal trig identities, just look at, well, first we're going to make the asymptotes for sine. Wherever the sine graph hits the 0 on the x-axis, that's an asymptote. Then the axis and right here. Using this, cosecant hits right there. You just make like sort of like a parabola going up here. And then down here. Then, just erase that part. Don't actually have to, but this part is the cosecant graph. Time for secant. Yeah, there's the cosine. Do the same thing wherever cosine equals 0 with the asymptotes. Let's see, wherever it reaches here, here. First go up, down, and up this way. So what you're left with, one's a bit harder to see. It's a little like frowny face, see? The eyes and then frowny face. Yeah. Last one is sort of my favorite. Cotangent graph. My favorite because if you put it with the tangent graph, it's just look around. Creates. Look, it's an X. And now it's sort of like through the stars. Yep. Now I'll just erase the tangent part. Ink and there you have it. Cosecant, secant, cotangent. Guys, guess who I am? Inconceivable!